Hello guys, this is CodeNCode and this is the fifth lecture of this dynamic programming series. And in this lecture we are going to solve this problem, chef got recipes. Before I start, I have two notifications for you. First, I have made a new account on Instagram, so you can follow me there because I keep on updating guys there about the new lectures I'm working on and any information that I need to share with you guys. So if you want, you can follow me there. The link of the profile is given in the description. And second thing, if you think that you can help me uh, with donation, you can. Again, the link of the UPI is given in the description. So anything you can, that would be appreciable. Thank you. So now let's start the lecture. So the problem is taken from CodeChef, and the problem is you are given n dishes. Each dish contains not digit, characters. So there are n dishes numbered 1 through n, and each dish contains number of characters. Each character would be from these vowels a, e, I, o, u. So you can prepare a meal from these dishes, and a meal contains exactly 2 dishes. So you can choose 2 dishes I and J, where I and J should be different of course, and you can prepare a meal. Chef likes a meal if it contains each vowel at least once. So you have to tell for the given number of dishes how many meals you can prepare which chef likes. So if we take an example, this is the test case 1 and 3, 1 test case and 3 dishes. This is dish 1, 2 and 3. So total number of meal which chef likes are 2, which are, if you take first 2 dishes, that is dish 1 and dish 2, you can combine those, and the meal contains all characters, all vowels a, e, I, o, u. So it contains a, e, I, o and u. You can see it contains all 5 characters. That is why the chef likes this meal. But if you combine dish 1 and 3, it doesn't contain u anywhere, so it doesn't contain every character, hence chef doesn't like this meal. But meal which is prepared from dishes 2 and 3 again contains all vowels, and that is why chef also likes this meal. So you from 3 dishes we can prepare 3 pairs of we can use 3 pairs to make 3 different meals, but out of 3 meals only 2 meals are there which contains all 5 vowels. So just think how you would approach this problem, and for constraints there are 10^3 test cases. Each test case can contain 10^5 different dishes. So n can be 10^5, t can be 10^3, and length of string can be, I guess, 10^5 again. Overall sum of the length of all string doesn't go beyond 3 into 10^7. So just think how you'd solve this problem. To solve this problem, we are going to use bit manipulation, or basically bit masking again. So what we would be doing is that, since we know there are only 5 characters, so we would be using a 5-bit numbers to represent each dish. So 0th bit would represent character A, first bit would represent character E, and second bit would represent I, third bit would represent O, and fourth bit would represent U. So what each dish is going to look like, it is going to be a 5-bit number. So since the first dish contains A and O, A is the 0th bit, so the 0th bit is set, and O is the, I guess, 3rd bit, so 3rd bit is set. So this dish can be represented or can be mapped to a number, and this number is actually 9, I guess, right? 2, 4, 8 and 1, 9. Yes, it is 9. So each dish can be, even though the size of the dish can be as large, I mean the input characters can be up to 10 to the power 5, but still the dish can be mapped to a number which is only 5-bit. Even though I'm talking about 5-bit, we would take it as integer which contains 32 bits, but the rest 27 bits are no use for us because they all is going to be only 0 throughout the processing of this throughout the mapping of this dish to integer. So that is why I'm not representing those 27 upper bits, only the lower 5 bits are meaningful to us for now. That is why only I'm showing the first 5 bits. Now this dish can be mapped to a number which is 10110, because it doesn't contain a, so 0th bit is 0, and it contains e, that is why the first bit is set, contains I, that is why the second bit is set, doesn't contain O, that is why the third bit is 0, and contains U, that is why the fourth bit is set. Same goes for this. You can map this dish to this integer or mask. So now how we are going to solve the problem if we have those masks, or basically you have converted those dishes into integers, how it is going to help us. So to explain that, I'll be solving the example problem, taking 3 characters only, and then we would extend our solution for 5 characters. For now, in the input I'm assuming there are only 3 characters, which are A, B and C. 0th character would 0th bit would represent A, first bit would represent B, and second bit would represent C. So now since we have only 3 bits, so the total number of combination can be 2 raised to the power 3, which is 8, which would be from 0 to 7. That is why I am having an array of size 8 from 0 to 7. Now how we are going to is, we are going to process each string one by one, and each time when you are going to process a string, you would initialize the mask to be 0. I'm representing the first 4 bit only, the rest 28 bits I'm not representing because those are no use for us for now. So you initialize mask to be 0, and then you start processing the characters of string one by one. So the first character is A. A indicates presence of 0th bit, that is why you are going to set the 0th bit in the mask. If you set the 0th bit in the mask would convert into 1, because if you take a number whose 0th bit is set, it represents a 1 in a decimal system. In the binary system it would be like, since this is 32-bit number, that is why the higher 31 bits would be 0, the only 0th bit would be set. Now we would go to the second character is B, and B represents the presence of the first bit, so we would set the first bit as well. Now the mask would convert to 3, because 1 is actually in 1 in binary is actually equal to 3 in decimal system. So now you have processed the string and your mask becomes 1 which is actually 3. So in the frequency array you would go into position 3 and increment the count. The rest are 0, this would become 1, which would indicate there exists a dish of type 011. 011 means of type AB, which contains A and B. Now we would process the second string, which would come out to be 0101, which is 5. 0101 because 0th bit is set because it contains A, second bit is set because it contains C, that is why it would become 0101, which is actually 5. So in the frequency array at position 5 you would increment the count, which would become 1. Now you would process the third string, which is actually BC. BC means the first and the second character would be set. So after you set first and second bit, it would become 6, and in the frequency array at position 6 you would increment the count. If you process the whole input, this is what frequency array would look like. Now once we have frequency array, how this is going to help us solve the problem. Now a dish or a meal would be tasty if it contains all characters ABC, right? So we see AB can be paired with any meal which contains C, right? So AB and AC, these two meals you can combine, so it would contain all characters from ABC, right? AB you can't combine with A because AB and A would contain only AB characters. It won't contain C, that is why it won't be a valid pair. So how we are going to find that? Using this frequency array. This is literally very simple. You start processing from 1 and till 7. So I is 1 currently, and they and then j would be I plus 1 to last, that is 7. So currently I is this, and for this I we are finding j from 2 to 7. Now j is 2, so you would perform OR operation between I and j. Now if you perform OR operation between I and j, I is 001, j is 010, the resultant would be 011, right? 011 doesn't contain all set bits because it doesn't contain all 3 bits set. That's why it can't form a valid pair. And if you see, 001 is actually A, 010 is actually B. So A and B can't make a string which contains all 3 characters. That is why these two won't form a valid pair. Now j would increment, j would become this. Now if you perform OR operation between 001 and 011, the resultant would again be 011. 011 again doesn't contain all 3 bits set, that is why this won't be a valid pair either. Now 001 combined with 101, if you OR these two, it would become 101, again not all 3 bits set, so we would continue, j would become this, the same would happen with this. But as soon as j becomes 110, which is I guess 6, so if you OR 001 and 110, the resultant would be 111, which is actually all 3 bits set, and hence this indicates that this and this can form a valid pair. 001 indicates A only and 110 indicates BC. It is actually clear that A and BC when combined together can form a valid pair. So that is why, how many total, first of all, these two would make a valid pair, and second, how many valid pair would be there? The total number of valid pair would be 2 times 3, because there are 2 A's and 3 BC. So total number of combination would be, total number of pairs would be 6. So in the result you would increment it by 6. As you can see, there are 2 A's and 1, 2 and 3 BCs. If you take 1 A out of these 2 and 1 BC out of these 3, it would form a valid pair. Total number of pair you can form are 3, 2 into 3. Total number of pair you can form are 6, because 2 A's and 3 BCs are present there. So in the result you would increment it by 6. And finally j would increment it, j would become this. If you perform OR operation between 001 and 111, it would form the resultant would have all 3 bits set. 3 bits set means 7 actually. So you can check whether OR operation between I and j is equals to 7 or not. So the resultant is 7, which means if you combine A with ABC, the resultant is going to contain all 3 bit set. Of course it is going to have all 3 bit sets. That's why these two also form a valid pair. That is why it would add 2 into 1, that is 2 into the result. So if we extend this solution to 5 bits, all you have to do, now we would have total number of 2 raised to power 32 different combinations. So we would have a frequency array of size 32, which would have from 0 to, which would have position from 0 to 31, and that is all we need. And to check whether two string make a valid pair or not, all we have to do is perform OR operation between I and j, and it should be equal to 5 set bits. 5 set bits means I'm talking about first 5 set bits. If first 5 set bits are set, the resultant is actually 31 in decimal, so we would compare with 31. And remember this 111, that is all characters present. If there were ABC 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 3 times, then they can form pairs with each other. First ABC can make a valid pair with second ABC, and first ABC can make a valid pair with third ABC. So if there are n number of ABC or n number of 111, n number of dishes which contain all characters, then they can form n into n minus 1 divided by 2 total number of pairs which are valid. So finally we would add that number into our result as well. So let's extend the solution. Let me just remove everything so that I can show you. Now this, or create a new file. Let me show you hash windows.h for a reason. Now let's solve it for 5-bit, because in the input we have strings which can contain character a, e, I, o, u. That is why for each character we would have a bit. So all I need currently is a frequency array of long int. Let's call it f for now, of size 32, because there are going to be 32 set bits. 5 set bits, which would contribute to 2 raised to power 5, that is 32 different configurations. Now we have t and n, t and n, and then we have dishes dishes which are given in the form of string, so that is why string st. So now t in each test cases we would be given n, and then n dishes in the form of string. So we are reading the ith dish, and then we are initializing max to be 0. Now this is enhanced for loop. What it does, it would take characters of a string st one by one. So if the character is acc, then first ch would become a, then ch would become c, and then ch would become c again. So this is enhanced for loop, or basically for each loop. So this traverses the characters of a string one by one. So if ch is equals to a, which indicates the presence of the 0th bit, so mask is equals to mask or with 0th. What this expression is doing, it is performing an or operation between two numbers, which is first is mask and second number is one left shifted 0 times. So one left shifted 0 times means a number whose 0th bit is set. So what this would do, this would actually make the 0th bit set in the mask. Okay, so if AE, so E would indicate presence of the first bit, so mask is equals to mask or with one left shifted 1 times. What this would do, this would basically perform OR operation between mask, and this is actually a number whose first bit is set only. So if you perform OR operation between these two numbers, mask would finally contain first bit set, and A, E, and then I guess I represent presence of the second bit. So mask is equals to mask or operation with one left shifted 2 times. So if ch is equal AEIO, mask is equals to mask O represents presence of third bit, and finally if ch AEIOU, so this represents presence of fourth bit. So this is how we process the whole string one by one each character of the we process each character, and if the character is A, we set the 0th bit. If the character is B, we set the first bit in the mask. If the character is I, we set the second bit in the mask, and finally for O and U we set third and fourth bit in the mask. And finally mask would become a number that ranges from 0 to 31, and in the frequency array at position mask we increment the count. Oh, it is important for each test case that we initialize the frequency array to be 0 or less than 32 I plus plus frequency of ith character is 0. Finally, after after reading all strings, now frequency array contains frequency of each type of just frequency of each strings one by one. Long int result is equals to 0. Now what we are going to do, basically we have prepared this frequency array. Now we would run an n square loop where n is actually 32 in our case, in this case, because there are the frequency array contains only 32 elements. So we would run a loop from 1 to I less than 32 I plus plus, because when we have 3 set bits we would start from 1 and move till this position, that is the end, that is 2 raised to power third, which is 8th position. 2 raised to power 3 minus 1, because first 3 set bits means 2 raised to power 3 minus 1. So first 5 set bits means 2 raised to power 5 minus 1, which would be 31. So we would start from first position, will move on till the last position, and for it we would run a loop j from I plus 1, j less than 32, and j plus plus. We would try to make a pair of ith type of dish with jth type of dish. So if I or j, if they have all first 5 bits set, then it is going to be 31. So if I or j is equals to 31, which means I and j forms a valid pair of dishes which would make a valid meal. If that happens, then we can add result is equals to result plus frequency of I into frequency of j. And now after we have processed all I and j, we have tested for each valid pair. Now these can form pair with itself. If there is a string for 3-bit number, if I explain, if there is a string of abc 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 type abc 3 times, then it would form 1 2 and 3 valid pair. First abc with second abc would form a valid pair. First abc with third abc would form a valid pair. Second abc with third abc would form a valid pair. So we would take count total number of, if the total number of a string of type abc are x, then the total number of pairs would be x into x minus 1 divided by 2. So in our case, where number of bits are 5, so the last one is here at this position. So all dishes of type 1 1 1 1 1, that is all characters present in those dishes, they can make pairs with themselves. So this would also add into result. So result is equals to result plus n into n minus 1 divided by 2, and finally you would print result. So this should work. Chef and recipes, just a second. Let me show you the problem page. This is the problem page. So let me, yeah, these are the constraints. Each dish can contain characters up to 1000 characters. So let's test for first test case. I hope this works because the result is 2, which is good. So let's submit this real quick. Okay, submit. Yeah, I hope I've made no mistakes. Compilation error. Oh, sorry, I know what it is. Come on. Oh, I know where the problem is. This extra code, let me remove this is the problem, and this. So windows.h header file and that extra code that I write is. So now let's submit. I don't think we should get any error this time. Okay, running. Yep, you got an AC. So this is how you solve this problem using bit masking. I think this should be the last video on bit masking. I'm explaining this so that we can use bit masking in DP. Till now we are not using it as DP because this is simply bit masking, not DP, because we are simply generating all possible subsets till now. Later we will see how bit masking can be used with DP. So thank you guys for watching, and I hope you have learned something from it. So till the next video drops, keep coding. Thank you.